Hey guys, Steve here. Today in this video, I'm going to be showing you how I set up an ambient light project on my TV using software called Hyperion. Now in this project, we'll be setting up an LED light strip around the frame of my TV. And then we'll be using a Raspberry Pi to capture the video that is being displayed on the TV and change those LEDs accordingly to what's on the screen. That way that anything that is displayed on my TV will be splashed up with light on the back wall behind the TV. Now in the past, setting up this video would be pretty difficult. I've seen a lot of videos over the last couple of years of people setting this up, and you had to use multiple pieces of software to set up configuration files to get it to work on a Raspberry Pi. But over the last couple of months, the people who are working on Hyperion have made it a web-based setup. Now there's no configuring any configuration files. We just have to go to a web browser, run it on a Raspberry Pi, and set up all of our commands. So we're going to be using a Raspberry Pi for this project, and you can use any Raspberry Pi that you have. In my project, I'm going to be using a Raspberry Pi Zero-W because we do need to have Wi-Fi on the Raspberry Pi, since everything is set up over a web-based browser. So one of the first things that we're going to be needing is an LED light strip, and we're going to need a specific one, a WS2812B. Now this is a LED light strip where every LED can be controlled individually. You may see some cheaper LED light strips that are out there, but those ones cannot change every individual LED to a different color. On those, all the LEDs are all the same all the time. Now the next thing that we're going to need is an Arduino, and this is actually used to control the LEDs individually. The Raspberry Pi will analyze the video and it will tell the Arduino which LEDs need to be changed, and this is what controls the LEDs. Now this is an Arduino Uno. This is a legitimate Arduino. This one costs about $23. Now I did buy some generic Arduinos to see if they work, and they work just fine. I picked up this Arduino Nano clone that works perfectly fine. I was able to find 3 of these for about $13 on Amazon, so that brings my cost to about $4 a piece. The ones that I picked up already had the headers pre-soldered onto it, and they all came with a USB cable. Now we will need the USB cable because this is going to plug into the Nano, and then it's going to be plugged into our Raspberry Pi. Now like I said, I'm going to be using a Raspberry Pi Zero-W, and that only has 1 micro USB port on it. So we will need to buy a USB hub. And the one I bought has 4 standard USB ports on it, and it has a micro USB port on it that will plug into the Raspberry Pi. So we'll plug the Arduino Nano into this, and then we're going to use one of these other ports to plug in an HDMI capture card. So this capture card I picked up on AliExpress for about $6. They do sell very similar ones on Amazon for about $25 because they are being price gouged right now. The one good thing about Amazon is that they do have a return policy, so if something is wrong with it, you can return it easily. Since I bought this on AliExpress, returning this would be difficult if something was wrong with it. But for $6, I took the gamble. So this is just going to also plug into the USB hub. Now the reason that we need a capture card here is because we're going to feed in our video source coming from our cable box, our Xbox, our PS4, our Roku. We're going to plug one of those devices directly into this device and have the Raspberry Pi analyze the video. Now since this capture card only has an input setting, we will need to also buy a HDMI splitter. So this has 3 ports on it. We have a HDMI in, so this will come from our cable box or Xbox, PlayStation, Roku, any HDMI device, and will has 2 outputs. One of these outputs is going to go directly to our TV, and that is the source that we're going to be watching. Now output number 2 is going to be going to the capture card using an HDMI cable. Now this device does need power to it, so you will need to have a USB power supply for it. And this one that I bought came with a USB cable with it. Now going back to capture cards, a lot of the videos that had been out for the last couple of years, they were not using an HDMI capture card. But in the latest software, they now support HDMI capture cards over USB. Now this capture card is only USB 2.0. Now for the project that we're setting up, we do not need USB 3.0 because we do not need a high quality video. The video that we're going to be inputting in this is going to be very low quality image anyways, so it really doesn't matter. So keep that in mind when you're searching for these. You only need USB 2.0. Now a lot of the older videos that are out there, people are using this type of capture card. It's USB 2.0 and it has RCA cables onto it. Now this capture card still works, but it's not as convenient as the HDMI capture card. Now with this device, you would have also had needed a HDMI to RCA connector. That way you can take a RCA yellow cable, plug it into there, plug it into this capture card, and then plug this into the Raspberry Pi. Now this device also needs USB power to it, so if you have this set up and still want to use it, it still will work. Now like I said, I picked up this one for about $6 on AliExpress. It took about a week and a half to get to my house, but it is cheaper than buying these two devices to set it up. Now before we go start setting all this up, the last thing we need to talk about is power. These LED light strips use a lot of power. Now a standard USB plug like you use for your phone is not powerful enough to control these LED light strips. Now these LEDs that I have run on 5 volts. This is a 5 volt charger, but it does not have the amperage that we need to control it. So what we need to use is either a big power brick like this, or in my case, I'm going to be using a computer power supply. I'm going to show you how I set mine up in a second, but let's talk about this. Now the LEDs that I have around my TV, I have 110 LEDs around the border, and that uses about 7.5 amps of power at 5 volts. So that equals about 35 to 36 watts of power. Now on these power supplies, we need a power supply that actually has a wattage higher than that 36 watts. So when you're looking for a power supply at 5 volts, get one that's about 10 amps. So 5 volts at 10 amps. Now you can buy a big power brick like this, and I'll leave a link down below to one that might work for you. But for me, I'm going to be using a computer power supply. I have an old computer around my house that is now obsolete. I ripped out the power supply and I'm going to use this to power the LEDs. If you're to look at the power supply and all these little plugs that plug into like hard drives, this red wire right here is 5 volts and this black wire is ground. So I'm going to be stealing these 2 wires off this power supply to control the LED light strip. On the LED light strip, it comes with this little connector here that has 3 wires. It has a red wire for your 5 volts, a white wire for my ground, and it has this green wire for my data pin. And this is the wire that gets connected to the Arduino. And we'll go over that more in a second here. So now I'm going to show you how I actually have all this set up. And then we're going to start getting into the software side of it. So this is my little project board that I just built today. Here's my computer power supply. I've actually ripped out all the wires out of here, and I'm only using a black and a red coming out of here. I actually installed a USB port also into this, where I've tapped into the red and black wires and connected it directly to that USB port here. And this USB port I actually ripped out of the computer that I was using that I stole the power supply from. So coming out of the power supply, I have a USB cable that goes into the Raspberry Pi. I have a cable coming out that goes to the USB hub. Here is my HDMI capture card. This blue wire right here is a USB cable that goes down to the Arduino Nano. So I have a wire that's coming out of the digital 6-pin of the Nano, and it goes down to this little terminal block that I set up with a couple screws. And then down here is the little plug that plugs into the LED light strip. Now there's 2 important things I want to talk to you about when it comes to the power supply. If you end up using one of these computer power supplies like me, you may have noticed that mine has an on-off switch on the power supplies. Some of them do not have that on there. But the one thing with these power supplies is these are designed to work with a motherboard connected to them. So just by turning on this on-off switch, it will not turn on the power supply itself. So the one thing we're going to have to do is we're going to have to modify the power supply a little bit, which is done pretty easily. If we were to look at our power supply and grab the really fat connector that connects onto the motherboard, if we were to look at these wires, the 4th wire over is a green wire. This green wire connects to the computer motherboard and detects when you push the power button on the computer. So what I did was take these 2 wires, the green and the black, I stripped them out, tied them together, and now whenever I add power to this power supply, it'll turn on. Or in the case of mine, anytime I turn the on-off switch, it'll power on the power supply. I'm going to be connecting this entire setup behind my TV, so I will not have access to the power supply to turn on and off the lights whenever I want to use the TV. Now, whenever we turn off the TV, it's not going to automatically turn off the power supply and the lights behind it. So we need to figure out a way to turn those on and off. And what I'm going to be using is one of these sawn-off power outlets. So this will allow me to use my Amazon Echo or my Google Assistant to turn on and off this outlet, which will then turn on and off my power supply. Now, I did a review on these sawn-off power supplies in the past, so if you want to see how these work, I will leave a link down in the description below. Now, the next thing I want to talk to you about is setting up a common ground for your power supply and your Arduino and Raspberry Pi. Since I'm using one power supply to connect all this together, I already know that they have a common ground through the common ground of the power supply. But if I was to use a wall plug like this and say a phone charger to connect to the Raspberry Pi and this control the lights, we need to set up a common ground between these two different power supplies. And in that case, what I would have done is I would have taken the black wire out of my power supply and connected it to the ground wire of either the Arduino or the Raspberry Pi. Doing so creates a common ground and will get rid of any problems you may have controlling your lights later on. If these things do not have a same common ground, the lights might not operate as you expect them to. Now, before we start setting up the software on the Raspberry Pi and the Arduino, we need to talk about the number of LEDs that we have on our TV. So I've gone ahead and I've turned around my TV here, and I've showed you this is where I'm going to install my entire setup. Now, I'm using the bolts that are used to wall mount the TV because I do not actually have my TV mounted on the wall. So there are 4 screws on the back that I'm just mounting this entire setup onto. Now, I'm going to be starting my LED strip down in the very center bottom. And you can actually set it up anywhere on the TV because we can tell the software where we have it set up. So I'm going to be starting my LEDs here, and I'm just running them around the edge until it gets back to the center here. Now, I do have extra wires that are sticking out of the end, and these LEDs can actually be cut. There are metal contacts in the center of every single LED, and it has a little line that shows you that you can cut them. So I'm just going to be setting my LEDs behind the TV and not cutting them. I'm not worried about it. Now, on the corners, I've actually just rounded my corners, not cutting the LED strip. Now, you can cut these LED strips and resolder in some wires in between each LED set. But for me, it's just easier to round them there, and I don't have to cut, don't have to solder, don't have to do anything else. So right now, I've just temporarily taped them onto the TV, and later on, when I'm all set and done, I can remove the backing of the LED strip, and it has a piece of double-sided tape onto it, which I'll just double-side onto the back of the TV. Now, on these LED strips, you're going to see a little arrow that'll show the direction that the LEDs work in. So go ahead and count the number of LEDs you have on each side. Now, I have already set this up, so I have 20 LEDs on the side and 35 across. So when I add all those numbers together, it comes out to be 110. Now, we will need to know that 110 so we can tell the Arduino how many LEDs we have set up. Now, before we leave the back of the TV, I want to talk about this HDMI splitter I have. Now, I did not install this on my project board because I'm going to be using a separate power supply for this. And the reason for that will be those occasions where I do not use the backlights, but I still want to be able to watch TV. If this was plugged into this power supply, this would only turn on when this power supply is turned on. Now, those rare occasions where I'm going to be watching TV without the backlights, I'm going to either power this separately with a wall plug, or what I'm going to try doing is plugging it into the USB port on the back of the TV. That way, when the TV powers on, it'll power on this HDMI splitter. That way, anything that comes into the HDMI splitter can then be shown on the TV. Now, like I said, if this was plugged into this power supply, the lights would have to be on for this to turn on anything that is being plugged into it. So keep that in mind when you're setting this project up. Now let's go ahead and we'll start setting up all the software for this project. Now, for setting up our software, the first thing we're going to set up is the software for our Arduino. Now, like I said, you can use an authentic Arduino, or like me, I'm going to be using a generic clone of an Arduino. Now, there is a little bit of difference between these two devices because they each use a different device driver to be able to program them. So the first thing we're going to do is we're going to go ahead and go over to create.arduino.cc and create an account if you do not already have one. This will allow us to use their web editor to be able to install our program online and then be able to transfer it over to the Arduino using a USB cable. Now if you're using this web page for the first time, it'll tell you that you need to install a plugin for it, which will allow you to be able to send the program from the web page over USB to the Arduino. And like I said, these two devices use a different plugin, so you will need to install a device driver for any clones that you decide to use. So once you have your account created for the Arduino website, go over to my GitHub page where I will have all the software that you need to install this program. At the very top, I have a link called Arduino Code. If you go ahead and you click on that link, you can then go ahead and copy all the instructions here on this page. So go ahead and select that, and hit Control C, and we're going to go back to our Arduino editor. At the very top, we're going to go ahead and create a new sketch. And in this page, we're going to select everything that's there, hit Control Paste, and it will paste all of our instructions there. Now at the very top of these instructions, the very first line says it includes Fast LED. This is a library that is part of the Arduino that does all the math formula that we need for our project. If you were to go over to the Libraries tab and go to the Library Manager, you can now search for Fast LED, all one word. And the very top one will show up, so you can go ahead and you can favorite that. And now that you favorited it, it will be able to give you examples of how to use this software, but you do not need to do anything else with that. So if we go back over to our code over here, the fourth line will say define number of LEDs. And this is where you would enter in the number of LEDs that you have installed on the back of your TV. Now I have 110, so I have put 110 on line 4. Line 9 talks about data pin 6, and that is the little pin that is on the Arduino, and that's the one that's going to be connected directly to the LED strip. Now the next thing that we need to pay attention to is line number 18, which says define serial baud. Now this says 500,000. Now you need to remember 500,000 so that we can enter that onto the Raspberry Pi. That'll allow the Raspberry Pi and the Arduino to talk to one another, so it knows a baud rate. Now I'm going to go ahead and I'm going to plug this into the computer, and I'm going to wait for that to boot up. And on my screen it says the board has now been connected. Now once we've entered in all of our code onto the web editor, up at the very top where it says verify and save and it has the arrow to upload and save it, we're going to go ahead and we're going to select our board type that we have. So if we click this and we select other board and port, we can now search for the type of board that we have. So I have an Arduino Nano, so I'm going to select Arduino Nano. It already detects that it's on COM4 of my computer. Yours will probably be different. And next it has the flavors. Now the default option will not work for the clone of mine, I know for sure. So if I select my flavors and I select the old bootloader, this will work for my clone that I have. So keep that in mind if you're using a generic Arduino. Next, go ahead and hit OK. Now we can go ahead and we can hit the upload and save. This will save our code and then upload it onto the Arduino. So go ahead and hit that, and we'll wait for that to install. Now once we're done with the Arduino, we can go ahead and move on to the Raspberry Pi. Now, I'm going to leave a link down below and on my GitHub page over to the Hyperion download. Now this is just a copy of Raspberry Pi OS Lite with all the software pre-installed for Hyperion. Now it is a complete image that all we have to do is download the image and burn that image onto a SD card to put in our Raspberry Pi. So go ahead and download the image, and then you can go ahead and use Win32 Disk Imager, or if you're on Mac, use Etcher. I will leave a link to both of those pieces of software down below as well, so if you need those, you can download them. So on Win32 Disk Imager, because I'm on a PC right now, I'm just going to take my image that I have, and I'm going to go ahead and search for it on my desktop where I have it downloaded. Select it. And now I can go ahead and put my SD card into the computer. Now you need to make sure that you are selecting the right SD card. This will completely erase anything on this card and install our software onto it. Now make sure you're not selecting any extra hard drives that you have, because it will completely erase everything. You are warned. So I'm going to go ahead and open up File Explorer and make sure that I know exactly which SD card that I'm going to be using. For me, I'm going to be using my G drive. So I'm going to go ahead and go back to the Win32 Disk Imager, and I'm going to select my device as G. Next, I'm going to go ahead and I'm going to write this file onto the SD card. This will take a couple minutes to install. Now you only need an SD card that's about 4 gigabytes large. You do not need to go any bigger for this project. Now it will warn you that it will completely erase the drive. Everything that is on here is now gone. Now with our image burned onto our SD card, we can now go ahead and we can set up 2 more files onto that SD card. One is going to be setting up our Wi-Fi for the Raspberry Pi, and the second is going to be allowing for SSH onto the Raspberry Pi. So go ahead and close out of the Win32 Disk Imager if you're using that. And we're going to go over to our File Explorer. In File Explorer, we're going to go ahead and search for that SD card onto our computer. Now mine is listed under my F drive. Now, here we're going to be installing 2 files onto this SD card. And now the first thing we want to do is we want to go up to the View option onto our File Explorer and search for the option that says File Name Extensions. We want to be able to see the file name extensions. So make sure that box is checked. Now we're going to go down to the section that shows all the files that are on the SD card. And we're going to go ahead and we are going to right click into that folder. And we're going to go down to New. And we're going to search for Text Document. Here it says New Text Document.txt. Right here we're going to type SSH and we're going to delete the .txt. So all it is just SSH. That's it. Go ahead and hit enter. Here it's going to ask you if you want to change the file extension. Say yes. Next we'll go back to my GitHub page and we're going to go back to the main menu and we're going to search for our WPA_supplicant.conf file. This file is the settings for our Wi-Fi configuration. Now if we go ahead and select every line there and hit Control-C to copy it. Now once we have all those lines copied, let's go back to our File Explorer and we're going to once again right click in that folder, go down to New and Text Document. We'll double click on that and we're going to open it up to show a new window here. And hit Control-V and paste all of those lines into this folder here. Now on the 1, 2, 3, 4, 5th line here, we're going to enter our Wi-Fi name of the Wi-Fi of our house. And then the next line, we're going to enter our password of our Wi-Fi in our house. Once we do that, we're going to go ahead and go down to File, Save As, and we're going to name this file the WPA_supplicant.conf file, the exact same name that we downloaded from off the GitHub. And let's look for it on our drive here to make sure that it showed up. And when we look at our File Explorer, it saved it as WPA_supplicant.conf.txt. We need to remove that .txt off this file. Let's go ahead, click on it, right click, and go over to Rename, and delete the .txt file. Hit enter. It'll ask us once again if we want to change the file extension type. Go ahead and hit yes. Now with those 2 files installed onto the SD card, we can now take the SD card up and put it into the Raspberry Pi. Let's go ahead and we will power on the Raspberry Pi and we need to find out what the IP address of the Raspberry Pi is. Now there's 2 ways of doing it that are pretty simple. One, you can plug in an HDMI cable into the SD card, look at it on your TV, it will display the IP address on your screen there. Otherwise you can log into your router at home and find the IP address. So I've gone ahead and gone to the IP address of the Raspberry Pi :8090. Now when I've entered that into a web browser here, it's going to bring up the dashboard on the Raspberry Pi. So if we go ahead and we go to Configuration, go to General, this page right here we do not have to do anything in. The next thing is going to be our LED hardware. Now for the LED hardware, we're going to be setting up the programming for the Arduino. Before we plug the Arduino into the Raspberry Pi, let's go ahead and we'll SSH into the Raspberry Pi. This is going to be very important so we can find out what the actual address of the Arduino on the Raspberry Pi is. So go ahead and we're going to open up PuTTY or a terminal window if you're using Mac. And we are going to SSH into the IP address of the Raspberry Pi here. And when it brings us to our terminal window, we're going to be logging in as the default username and password for Raspbian, which the login is Pi and the password is Raspberry. Now once we've logged into the Raspberry Pi, we're going to type the command ls/dev/tty asterisk. When we hit enter, this will give us a list of all the devices that are attached to the computer that start with TTY. Now we'll go ahead and we'll plug in the Arduino onto the Raspberry Pi. Now after a few seconds, we're going to type in the exact same command and hit enter. And now we're going to compare these two lists to one another. Now on my screen here, I see there is at the very end, tty/USB 0. That is not in the first list, it's in the second list. That means that is talking to the Arduino. So we need to remember that address. Now we're going to go back to the web page on the Raspberry Pi at the LED hardware. When it says LED controller, we're going to go to controller type, and we're going to change that to USB, then down to add a light. In here where it says output path /dev/ttyACMO, we're going to change that ACMO to the USB 0. If I was using this actual Arduino, that line I would not have to change, but since I'm using a generic one, I need to change the address to the tty USB 0. Next, we're going to change the baud rate. The baud rate needs to be the exact same baud rate that we've entered into the Arduino web editor. For us, that was 500,000. The other thing we might have to change in the future if our lights don't work properly is this RBG byte order. Right now it says RBG. Once we have all this set up and we start testing it, if our lights are opposite of what they should be, if a red corner is green, we might need to change this. So leaving that default, we'll just change the output path and the baud rate, and we're going to go ahead and hit save settings. Next, we're going to go to LED layout. Here we are going to be entering in the number of LEDs that we had around the border of the TV. So at the top of mine, I had 35. Bottom, I had 35. My left side, I had 20. My right side, I had 20. And once we've entered in the number of LEDs we have, on the right hand side, it will show that we have a total LEDs of 110, and it shows our max power consumption of 7.3 amps. Now, like I said very early on, 7.3 amps times 5 volts is around 35 to 37 watts of power. That's why we need such a large power supply. This right here will show us how many amps that we're going to be using. So you can use this as a gauge to decide how big of a power supply you need. Going back here, we're going to go to input position. Right here, we can change where our LEDs start at. So for me, I started at the center of the TV. So if the TV's here, I started in the center bottom and I went around to the sides. So if I change this input position, just keep changing it, we'll see our little screen changing to where it'll set up here. So if I have my input position starting at the very bottom, we can now select our order that we had. So if you remember, my LEDs started at the bottom and they worked to the left, then they worked up, right, down, to the left. If we were to use this little schematic here, the black dot shows our first LED and the gray ones show the second and the third, and it will show our order there. Once we have that layout set, we're going to go ahead and we're going to hit Save Layout. Once we've saved our layout, we can now go to our capturing hardware. Now we can go ahead and we can plug in our HDMI capture card into the Raspberry Pi. Now we need to wait a little bit for that device to actually register with the Raspberry Pi, and you may need to refresh the page or even restart the Raspberry Pi if it doesn't detect it. But once we're on the capturing hardware, at the very top where it says Instant Capture, Enable Platform Capture. So the first thing we're going to do is disable the platform capture. We do not need that option, and it just becomes a headache if you leave that there. Next, we're going to go down to the bottom where it says USB Capture. And here we're going to select our device, and we're going to go to the UVC camera, which is my option. Next, we're going to select our video standard. You can select it to automatic if you want. I'm going to select it to NTSC, which is the North American standard. Next, we're going to go to device resolution. If you leave it at automatic, the Raspberry Pi could try to capture a 1080 image. Capturing a 1080 image is going to put a lot of strain on the Raspberry Pi. We do not need that option. Remember, our LEDs only have 110 LEDs around the border, so we can select the very bottom option, 640 by 480. Doing so will take a lot of strain off the Raspberry Pi. And by taking more strain off the Raspberry Pi, it'll keep the lights in sync with what's being displayed on the TV. Now, once we have saved those three options, we can go ahead and hit Save Settings. Now, the last thing we do before we test our LED light strip, we're going to go ahead to the very top of the capturing hardware page of the web page, and we need to make sure that it says enable USB capture. That will make sure that the HDMI capture card is enabled, so it will capture our footage that is going through it. Now, the one cool thing I want to show you about on this page here is at the very top there is a picture of a computer monitor or a TV that if you click, it'll then show you a picture of what is being displayed on the HDMI capture card. So right now you can see my TV is on YouTube, and on my screen I show a very pixelated version of YouTube. Now, it doesn't matter that it's pixelated because we do not care about the resolution on the Raspberry Pi. Now, if we click this option that says Live TV, it'll show you a live version of what's being displayed. So I'm going to go ahead and I'm going to start a color test that I found on YouTube, and now it's being displayed on the computer monitor here as well. So I can tell that these colors are not synced up, so we need to change a setting on the web page here on the Raspberry Pi. So if we close out of this window and we go back to our LED hardware, we can now go back to the section under LED controller where it says RGB byte order. Now, the default is red, green, and blue. Well, if we were to change these to one of the other options and hit Save Settings, so we're going to see the Raspberry Pi go through a series of colors to show that something has changed, and now when we watch it, we are still not seeing the colors show up correctly. So we can keep going through these different options to find one that works best for us. For me, I know it's green, red, blue. So if I click this and hit save, it'll flash at us again. And now I can see that my colors are now showing up correctly. So overall, this is a pretty simple project to set up now that we can use a web browser to configure everything that we need to do. Now, if I was to do this again, I would probably invest in a LED strip that has more LEDs to it. Right now, the set that I have is about 16 feet long and only has 150 LEDs. Now, I would probably get one that has 300 LEDs for my setup because the wall that is behind my TV is a darker gray, so it does not reflect a lot of light. Now, if my wall was white, these lights would probably work a lot better than they are right now, but because of the dark wall behind it, it kind of absorbs a lot of that light. Now, I'm going to leave a link to all the hardware I used to build this project down below in the video description, so be sure to check that out. And I will leave a link to all the software that I used for this project as well as a link to my GitHub page that has all the code that you need. So if you have any questions or comments about this project, leave them down below and I will try to help you with them. Now, the one question I'm probably going to get is, how do I capture the video source of my smart TV? Well, unfortunately, this project will only work with an HDMI source. So your smart TV does not have an HDMI out that you would be able to capture into the Raspberry Pi. So unfortunately, it will not work with a smart TV, but it will work with any HDMI source that you plug into the Raspberry Pi, like your PlayStation, your Xbox, your Roku sticks, your cable box, anything like that. But unfortunately, your smart TV, it will not be able to capture what is being displayed on the TV itself. Now, if you guys found this video useful, be sure to give me that thumbs up so I know I did a good job. And be sure to subscribe to my channel as I will have more Raspberry Pis coming out in the future, so stay tuned for that. Thanks for watching, guys. Have a good day.